Hello, everybody, and welcome to the second lecture from 7.3 and 7.4. This one technically from 7.3, and we are going to basically be doing mole problems today. The same type of mole problems that you did in chapter 3 when we were still in the building. If you can look back at those, we went through and converted from atoms to moles using Avogadro's number. So your equality there was 1 mole is 6.02 times 10 to the 23rd. And then we did mass to moles or grams to moles. And that was your value from the periodic table. And then we also did 2 liters or volume of a gas at standard temperature and pressure, STP, and that was 22.4 liters in 1 mole. So those were your 3 equalities. Remember, everything we did, whether it was going from grams to liters or atoms to moles, we used one of those 3 conversion factors. And again, those are 1 mole is 6.02 times 10 to the 23rd. In this case, we'll use molecules or formula units. That's what we call ionic structures instead of just atoms, because now we're using compounds instead of elements. But that's really the only difference. Then 1 mole is the mass in grams from the periodic table. Again, a compound instead of an element. Basically what you did last class is that you figured out the molar mass of the substance or the formula mass. And then finally, this one doesn't change at all. 1 mole of any gas at STP occupies 22.4 liters of space. So the only difference here, again, instead of elements, we're using compounds. So we have this molar mass, which can be used as a conversion factor. Okay, so let's go on to the next page here. And we're just going to start into some of these mole problems. For your homework tonight, you just have to go through. There's 6 of them that you have to do. And show your work there and make sure you check through the answer key to make sure you're doing these correctly. But really, like I said, if you had these down in chapter 3, you should be in good shape. If you need to go back there and take a look, we also had a mole roadmap that you could use if you want to use it as a reference. The other thing you'll need here is a calculator and your periodic table, okay, in order to get some of these values. So here's our first example. How many moles are there in 47.3 grams of NaHCO3 or sodium bicarbonate? So again, I'm going to be changing to my pen here. Please bear with me with this writing. And I am going to use a few shortcuts. Like I'm not going to write in the whole substance like I normally would. But make sure when you check the answer key that you have those down. So remember that you're always going to start with what you're given. So we have 47.3 grams of NaHCO3. And here, again, that's where I would write that. Okay. So then we're going to factor label. Okay. So remember, the unit you want to cancel goes on the bottom. So we're going to have grams down here, and that's going to come from the periodic table. And remember, all of these equalities are equal to 1 mole. Okay. So we have 1 mole will be a certain number of grams of NaHCO3. Now in chapter 3, this was pretty simple because we just had 1 atom. So it would be like sodium, and then you look up sodium, 22.99. But now we just have to do what you did, like I said, the last class, and add this all up. So the mass of 1 sodium, 22.99, 1 hydrogen, 1.01, 1 carbon, 12.01, and 3 oxygen, so 3 times 16. That gives you 84.01. Okay, your grams cancel. Okay, you're left with moles as your unit. Now remember, you just divide anything that's on the bottom, you multiply anything that's on top, and I will go to my calculator here. 47.3 divided by 84.01. I get 0.56302.821. 3 sig figs. Remember, the number you start with, that's going to give you sig figs. So that's going to be 0. Remember, that one doesn't count as a sig fig. 0.563. And that's going to be moles of your substance, which in this case, and you should write that NaHCO CO3. So 0.0563 moles. Okay, this was just one step. Grams to moles, we divided by the molar mass. Okay, so let's erase that. If you need to, pause and take a look at that for a second, you can. Let's move on to our next slide. So how many grams are there in 0.250 moles of Al2, the quantity SO4 taken 3 times? So that's aluminum sulfate, and we're going from moles to grams. So we're still going to start with what we're given, 0.250, and that's moles of that aluminum sulfate. Okay. And now I'm going to factor label here. There we go. Now remember, moles are going to go down here, so it's always equal to 1 mole. In 1 mole of any substance, there's a certain number of grams, and that gram amount is going to come from aluminum sulfate. So you'll go 2 times Al, which is 26.98. Remember, distribute this 3. 3 times 32.07, which is S, and 12 O's, 12 times 16. That's a pretty massive compound. It gives you 342.17. Okay, your moles cancel. Now you're just going to multiply. 0.250 times 32 or 342.17. So 0.250 times 342.17. And I got 85.5425. 0.250 has 3 sig figs, so my answer will have 3. So that's going to be 85.5 grams. Okay, 85.5 grams of Al2SO4, the quantity taken 3 times. Okay. Remember, the unit you want to cancel goes on the bottom, always equal to 1 mole. The unit you want in your answer goes up top. Okay, so let me erase that and move on to the next one. Again, if you need some time to take a look at these, just pause the video so you can take a look. Okay, now, here's one thing you have to be careful with. This is asking for molecules. Molecules and moles are different. Remember, molecules are those individual units, just like atoms. So that's where we're going to have to use Avogadro's number. The mole is that counting number that relates all of these things together. So we're going from grams to molecules. So that's going to be 2 steps. You're going to have to go from grams to moles, then moles to molecules using Avogadro's number, or 6.02 times 10 to the 23rd. So let's start with what we're given here. This one's going to be a little bit longer. 115.0 grams of CO2. Okay, so in our first step, we have to go from grams to moles. Remember, we can't go directly from grams to molecules. So in 1 mole of CO2, there's a certain number of grams of CO2. That comes from the periodic table. 1C, which is 12.01, plus 2 O's, which is 32. So we add that together, we get 44.01. Okay, grams of CO2. So your grams cancel. You don't have to do any calculations yet. Wait till you're totally finished with the problem. So now we have moles. We have to go to molecules. So now I'm really going to earn my money here with writing scientific notation. In 1 mole of any substance, okay, whether it is whatever. In this case, it's molecules. Could be pencils. There's 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd. And that's molecules. Molecules. So that says molecules right there. You have to look close. So now moles cancel. Our grams canceled. So we have to go on our calculator. 115 divided by 44.01 times 6.02 times 10 to the 23rd. Remember how to do this. Use the EE function. Okay, so I go 115 divided by 44.01 times 6.02 EE23, and then just hit equal. Okay, so when I do that, so if you have like an iPhone or something like that, if you turn it on its side, and most of you know this because we talked about it in class, you get all of those extra functions. Okay, so 115 divided by 44.01 times 6.02 EE23. I hit equal. I get this super long number, 1.57305157987. E24, we just have to write that back with 4 sig figs. So 1.573 times, don't forget the times 10, times 10 to, in this case, it's 24. Okay, and this would be molecules of CO2. That says molecules. Okay, 1.573 times 10 to the 24. Remember, you're dealing with molecules and formula units. That's just an ionic version. When you have metal, non-metal, you're going to have a big number because those molecules and formula units are so small. Okay, so this one was 2 steps. All right, let's go on to the next one. Let's erase that. Click over to the next one. So now we have these formula units of NiNO3 taken twice, so nickel 2 nitrate. We want to go to grams. So formula units, that's Avogadro's number. That's the same as what I just mentioned with molecules. Okay, so start with what you're given, 2.50 times, you'd think I'd get better at this over time, times 10 to the 24th. I need a mouse to plug in. I think that'd be easier. Okay, and this is formula units of NiNO3 taken twice. So I need to change that to moles by using Avogadro's number. So this is formula units, so formula units need to go down here. So we have 6.02 times 10 to the 23rd. Okay, there's that, and that's in 1 mole. Remember, all these are equal to 1 mole. I know I've said that a bunch, but they're equal to 1 mole. Okay, so now we have moles as our unit, and we need to go to grams. So our units there would cancel. We write those out, formula unit. You can write that out, formula unit. You'll see on the homework that it's written out. So now we have moles. We have to go to grams. So one more step. In 1 mole, okay, there's a certain number of grams. And that's going to come from the periodic table. So 1 Ni, which is 58.69, 2 Ns, 2 times 14.01, 6 Os, 6 times 16, and that gives you 182.71. 182.71. Okay, so moles cancel. So now on your calculator, 2.50. Okay, turn it sideways, clear. So I'm going to go 2.50 EE24 divided by 6.02 EE23 times, all in a row, 182.71. And that's around 758.76. So with 3 sig figs, 759 grams. 759 grams of NiNO3 taken twice. Okay, so formula units here, divide, then multiply, and you get 759. Okay, all right, last one. Now we're going to use our STP, our 22.4. Now on your homework, there I didn't put any of these ones on there, but it is fair game using this liter amount. So we're going from grams to liters. So we have to go grams to moles, then moles to liters. So 33.62, and that's grams of N2O5. don't know if I'm paused or not. What's up? He's in the shower? Okay, I'm almost done. Okay, so 33.62, we have N2O5. Okay. Factor label, grams are going to go down here of N2O5, so that's going to be 2 N's at 14.01 plus 5 O's at 16, and that's 108.02. 108.02 grams in 1 mole. The moles go up top. Grams cancel. Okay, now continue on. We're going to go to liters at STP. So remember, in 1 mole of any gas, and these are only gas, you can't use these for liquids or anything like that, it occupies 22.4 liters of space. So cancel that out there. So on your calculator, 33.62 divided by 108.02 times 22.04, or 22.4, excuse me. So 33.62 divided by 108.02 times 22.4. I get 6.972 with correct sig figs. Whoops. Okay, so 6.972 liters of that gas at STP, so N2O5. Okay, so those are your 3 equalities. 1 mole is 6.02 times 10 to the 23rd. Molecules, formula units, even atoms, if you do happen to have just one thing. 1 mole is the mass in grams in the periodic table, and 1 mole is equal to 22.4 liters of a gas at standard temperature and pressure. So go back and take a look at these. If you have any questions, your homework is very similar. Make sure you show your work. Make sure you write it all out. Okay.